All right, as promised, I have a problem similar to this week's workshop problem where we have a system with multiple things rotated, connected by various axles and chains. A bicycle is a great example of this because a bicycle has four things that are rotating. Actually, more than four, but we're going to focus on these four. We have the rear wheel, which is what actually touches the ground, the rear gear around which the chain is wrapped, the front gear that's right between your legs, and the pedals that you put your feet on. And since all four of these pieces are connected, if we know some information about all of them, for example, we know the radius of each of these pieces, then knowing one piece of information about one of them can help us learn just about anything we want to know about the other ones. So we're going to start by me telling us something about the rear gear. The rear gear is rotating at 64 revolutions per minute, and we want to answer a couple questions here. How far does the bicycle travel in 25 seconds? And how many rotations do the pedals make? So, there's a lot to keep track of in a problem like this, because not only are we going to have linear variables and rotational variables, both displacements and velocities, but we'll have separate variables for each of these four elements, for the rear wheel, the rear gear, the front gear, and the pedals. So I'm going to make something resembling a little table here that might help us out in keeping things organized. So I'm going to keep our linear and rotational variables separate from each other. And I'm going to keep our variables for each of these four pieces of the bicycle separate from each other as well. So I'm going to make one column for the wheel, one column for the rear gear, one column for the front gear, and one column for the pedals. There's no reason you have to show your work this way. I just think this is can be a helpful way to keep track of the many different variables that we're going to have that will often have similar names. Because we'll have a bunch of velocities, but they'll be linear or rotational or for about any of these four elements. So the linear variables that we can have are v, the velocity or the speed, and delta x or delta s, the linear distance. We have a particular formula to relate those linear variables to each other. Actually, let me pick a different color for formulas. Let's do blue. We have v equals delta x over t, where this delta x is actually not the displacement. It's technically the total distance traveled or the arc length, but your book calls it delta x or delta s, and I'm going to stick with that same notation. Then we have our rotational variables, which is our angular velocity omega and our angular displacement delta theta. And like with our linear variables, we have a formula that relates these two variables to each other. Omega is delta theta over t. Just like before, our velocity is our displacement over our time. So this can kind of help us keep track of everything that we need to know. So where we start off with, the rear gear is rotating at 64 revolutions per minute. So that's a variable that's about the rear gear, and it's a variable that's telling us how quickly something is rotating. So this is a rotational variable. So I'm going to call this omega r. So for these different pieces, the rear wheel I'm going to call W, the rear gear I'm going to call R, the front gear I'm going to call F, and the pedals I'm going to call P. And those will be my subscripts. So this 64 revolutions per minute is an angular velocity. It's some angle, some number of rotations over some time. but it's not in our SI units yet. So it'll be good to convert this into SI units first and foremost. So that will involve first converting the revolutions into radians, and there are 2 pi radians in every 1 revolution. So that would give us about 402 radians per minute. And then we'll want to convert that into seconds, because we want radians per second as our SI unit. And in every 1 minute, there are 60 seconds. So that gives us a final value for omega of the rear gear as 6.70 radians per second. So this piece of information, I'm going to circle in red, is our starting piece of information. And from here, we can get just about anywhere else in this grid to learn any other linear or any other angular variable that we want to know. And to show us how to get there, I'm going to do a couple example calculations. First, and I'll do this one in green, how far does the bicycle travel in 25 seconds? So whenever you look at a new question statement like this in this type of problem, or any problem, figure out which variable the problem's asking for. The variable is asking for, or the question is asking, how far does the bicycle travel? How far is asking for a distance, specifically a linear distance. So we already know we're looking for a variable somewhere in this top row, one of our linear variables. And how far is delta x? It's not velocity, it's distance. So what we want is delta x, but of which of these 4 rotating objects is the question. We want to know how far the actual bicycle itself travels along the ground, and there's only one piece of the bicycle that actually touches the ground. So the delta x we need here is actually going to be the delta x of the wheel. So delta x of the wheel, that is what we want, and we are going to try to get there. So, to do that, we need to get from the information we have some rotational information about the rear gear to linear information about the wheel. So to do that, we're going to need to go from one column to the other, or said a different way, we need to take the information we know about the rear gear and turn it into information about the wheel. So this is where the trick I've talked about in class is going to come in handy, because if we want to go back and forth between the wheel and the rear gear, we need to ask ourselves how those 2 items are connected. And these 2 items are connected by an axle. They share the same axle. And when things share the same axle, they have to rotate the same. One rotation of the rear gear is one rotation of the rear wheel. So, if things have the same axle, they will have the same rotational variables. So this means that WR here can also be reused, omega R, the angular velocity of the rear gear, is the same angular velocity of our wheel. So, just 1 second. So, our angular velocity of our wheel equals our angular velocity of our rear wheel because they share an axle. So this angular velocity of the wheel also equals 6.70 radians per second, not meters per second. So you notice that these are the same value for both the rear gear and the wheel, and it's the angular variables that are the same. So now we need a different kind of equation, because now we already have some information about this wheel column, but now we want to take information we know about rotational stuff and turned it into information we know about linear stuff. And if we want to go back and forth between linear and rotational variables, we have a couple of equations that will help us out here. One of them is delta x equals r delta theta, and the other one is v equals r omega. Sometimes you may have seen me write these differently. For example, delta theta is delta x over r, and omega is v over r, but those are just different ways to write the same thing. So, we have an angular variable right now, that omega, but we need a linear variable if we're going to find delta x. So, the linear equivalent of omega, the angular equivalent of the rotational velocity is the linear velocity. So, we can find v up here, because v equals r times omega. And whenever we write an equation like this, we want to make sure all of our variables are referring to the same piece of the problem. So if we want the velocity of the wheel, we need the radius of the wheel and the angular velocity of the wheel. So the radius of the wheel was given to us as 0.3 meters. And the angular velocity of the wheel we know is 6.7 radians per second from down here, because it's the same as the rear gear. So that means the velocity of the wheel, or the linear speed of the wheel, is those two things multiplied together, or 2.01 meters per second. And then, erase that question mark a minute. What was I on? Here, I guess. Okay. Delta x from this formula over here, rearranging that, delta x is just v times t. So if we want delta x of the wheel, we need v of the wheel times the time. Or 2.01 meters per second times 25 seconds. Sorry, I'm running over the edge here a little bit. That means delta x turns out to be 50.3 meters. And that's our answer. That is the linear distance, how far the bicycle travels in 25 seconds. So, let's go the other direction now. So in orange, now we want to figure out how many rotations the pedals make in that 25 seconds. So, if you'll give me just a second here. You don't have any reason to know this, but I'm going to need a little more space over here at the very end. So I'm going to make a little more space. So start with what the problem is asking for. How many rotations do the pedals make? So we're asking about the pedals for sure, and rotations is probably going to be a rotational variable. So how many rotations isn't omega? Omega, the angular velocity, is how fast something is rotating. How far something has rotated is delta theta. So what we really want here is we want delta theta of the pedals. And that's our answer. That's where we're trying to get to. So you can see we have a lot of steps to get all the way over there. So right now, we need to start back from where we actually know information. We know information about the rear gear. So, if we want to get one step closer to the pedals, we need to go from the rear gear to the front gear. So, if we want to go from the rear gear to the front gear, we need to ask ourselves what's the same, or what is shared between these two pieces of our system. And the rear gear and the front gear are connected by a chain. And when two pieces have the same chain, or they have teeth from the gears that are linked up together, they have the same linear variables. So if we're going to make a kind of a cross connection like we did before, it's going to have to be a connection up here for the linear variables. So the first thing we need to do is go from our kind of rotational column for the rear gear here up to our linear column. So we'll still do this in red. So let's go from omega to v, because omega and v are the sister variables here. So v equals r omega. Again, we want to make sure all of our variables are talking about the same thing. This is the linear velocity of the rear gear, the radius of the rear gear, the angular velocity of the rear gear. So that means VR is this 0.04 meters times the 6.7 radians per second, which means the linear velocity of the rear gear is 0.268 meters per second. Just your friendly reminder that radians is a stupid unit. So if you may have noticed that this radians right here, where did it go? We kind of lost it. Radians kind of pops in and out of the math whenever we go back and forth between linear and rotational. So basically, whenever you use one of these two equations that I'm circling in orangish, yellowish right now, whenever you use one of those two equations, radians will either appear out of nowhere or disappear into the night. Radians is a unit in the same sense that y is a vowel. It's a unit sometimes only when we need it to be. But back to this linear velocity we found. We found this linear velocity for a reason, because the linear velocity for the rear gear is equal to the linear velocity for the front gear. So VF equals VR, which means our linear velocity for our rear gear is also 0.268 meters per second. So hopefully you see the connections here. So at the end of the day, we'll want to learn something about the pedals. So if we're going to get from the front gear over to the pedals, we're going to have to ask ourselves, what's the same about these two things? How are they connected? And like before, we'll find out that they have the same axle. Here it is right there. This is the axle that runs through the rear gear and the rear wheel. And then actually this is the one we need now. This axle up here is the one that runs through the front gear and the pedals. And then we've got the chain that connects the front and rear gears to each other. Same axle means same rotational variables. So we're going to need to know a rotational variable about the front gear first, and then we know that will automatically carry over to our pedals. So again, we're going back and forth between angular and linear variables here. So I'm not going to switch colors yet. I'll stay in red. So this time, if we want to go from V of the rear gear, V of the front gear, this should be, and we want to find omega for the front gear, well, omega is V over R, and if we want omega for the front gear, we need the velocity for the front gear and the radius for the front gear. So that velocity for the front gear we already know. It's the 0.268 meters per second. And the radius for the front gear is the 0.09 meters. So omega for our front gear equals 2.98 radians per second. And we've done this for a reason, because now we know this variable is going to be shared across this line, because omega for the pedals equals omega for the front gear, which means our angular velocity for our pedals is also this 2.98 radians per second. And now we have some information about omega, and we want some information about delta theta. So we have a formula that relates the two of those, the velocity and the displacement. This time we're dealing with the angular velocity and the angular displacement. So delta theta, let me clear off that little bit right there. There we go. Rearranging that equation on the far bottom left, delta theta equals omega times t. And if we want delta theta for the pedals, we need omega for the pedals. So this is 2.98 radians per second times our time, which is 25 seconds, gives us 74.5. But our SI unit here is radians, and we want rotations, so we're going to need to divide by 2 pi, because there are 2 pi radians in every 1 rotation. And that gives us, kind of run myself out of room here, but that gives us a final answer of 11.9 rotations of the pedals over the course of this 25 seconds. So it's a little complicated to see. Hopefully the chart helps a little bit, but just to kind of run through a lot of it again, whenever you're going between columns, so between different rotating elements from wheel to rear gear to front gear to pedals, the only way you can jump from one item to another is to know which variables they share, whether they share an axle or a chain. Here, we know that both the rear gear and the wheel have the same angular velocity because they share an axle. This is that axle right there at the rear of the bike. So they have the same angular variables. Here, we know the front gear and the rear gear share the same linear variables, like linear velocity, because they share a chain that I'm kind of attempting to trace out right now. And last but not least, we know that the pedals and the front gear share some angular variables because, again, they're on the same axle. You can see that axle right here that I'm shading in. So anytime you're going from one item that's rotating to another item connected to it, focus on what's the same, how they're connected, and what that means about the variables that they share. On the flip side of this, anytime you want to go from linear land to rotation land, we are using these equations right here. So if you just want to talk about, for example, the rear gear for a minute and talk about only the rear gear like we did, we started with something we knew, the angular velocity of that rear gear, and then we used one of those equations to take something we knew about the angular variables and to find something about one of the linear variables. So every time we were moving from linear to rotational, we were using these equations that I've got the big yellow arrow pointing to. And anytime we're going from one column to another, from one rotating element to another, we were going using our thinking about what's the same, what's shared between those two elements, so which variables have to be the same. Hopefully this helps in your preparation for the test on Friday. Feel free to drop by my office if you have any questions. Thank you and have a good day.